Steve here at West Green. I want to do something a bit different today. Often it comes up about wiring points, correct name is turnout, and people come up with things like, how do you wire a point up for DCC? As if somehow it's different than what I would call DC or analog. Let me tell you, there's no difference how you wire up a point. None. There's nothing fancy about DCC. And just so you know my background, I'm retired now, but I did study electronics at TAFE. I've got a diploma in electronic engineering, and whilst I've forgotten most of it, simple circuits like connecting something like a battery to a motor or a lamp and return, I think I can manage that. So, let's go a few things. I will argue that at any given time on a piece of track, DCC is exactly the same as DC. Now, why is that? Here is this is a graph. It's positive volts, negative volts. Negative volts just means the current is going in one direction as opposed to the other direction, plus minus. So with AC, and I've drawn a sinusoidal wave, which is what comes out your power, 230 volts AC, RMS. It starts at 0, goes to positive, comes back through negative, and starts again. That's called the period, and on the mains in the UK, it's at 50 hertz. That means this repeats itself 50 times a second. In America, they use 60 hertz, so the frequency is a bit higher, so it's 60 times a second. So what I'm saying is at any given time, and I'm just going to put my finger down somewhere, there, at that instant in time, it's virtually, you could say, it's just DC, or it's increasing. Doesn't matter. Now, I don't know what type of AC waveform goes down the DCC sends out, but it's AC. It might be, I don't know, it could be something like square wave or sort or like that. It doesn't matter. I don't know and I don't care. And I haven't got an oscilloscope to look. There's probably someone out there who does know, but that's not necessary for what I'm talking about. So that's AC. DC. Notice I put varying DC. We've got volts, time. Think of it this way. This is DC, right? And it's DC by virtue of the fact that it doesn't go past negative that way, and therefore it's varying like that. You could be like that. You could be running a train. As you turn it up, the voltage goes up. As you turn it down, it goes down. A battery, on the other hand, is like this. If you had a car battery, which is actually more than 12 volts, it's about 13.2. If you were to, with time, you get a constant voltage. It doesn't alter. Well, it would. As the battery decreases, it would gradually go down and down and down. So that's that. So, my next slide, if you want to call it, is to show a turnout. This is a turnout. Doesn't matter if it's what scale it is, 7mm, 4mm, 2mm. That is a toe end of a point. That is the heel end of a point. And the way I look at it this way, it's like looking at your foot sideways on, not your sole, but your foot. That's about to be sort of your heel, and but your leg would go up like that. Does that make sense? That's your ankle, and that's the heel toe. Now, one thing you do is you always feed power from the toe end of a turnout, right? Whatever it is, you feed it from a turnout. So let's look at a turnout a second, as if I've pulled it apart. This is a live frog, by the way, a live frog, which is actually called a common crossing. If I pulled the components out of it, took it all off the sleepers, I've got two stop rails. I've got a straight one and a curved one, or if it's a Y, they're both curved. They're stop rails. These are the switch blades, and that's called the common crossing. And that's normally given a number, like an 8 or a 7, which means that's the gradient of it. 1 in 8, 1 in 7. Obviously 1 in 8 is a shallower grade, like a hill. You know, you go along 8 and go up 1. Okay? And the stock rails, they're actually given numbers, like on proper turnout, say, like B, it's the length of the bay. So if that was a B one, you'd have a B8 turnout. And if it was a right, it'd be a B8R, or if it was a left, it'd be a B8L. But notice here, and I've pulled apart a live frog point. So I've got two stock rails. Notice here, I've got the two switchblades, and they're all connected to the frog, and I've just drawn a bit of a wire, so as if it's solder. All that is one piece electrically. So whatever's on that, whatever voltage is on that, is on that, is on that, is on that, and is on that. Hopefully, this is still making sense. So let's go to my next slide, and I've coloured this one. Let's have a look at bog step. Well, I'll pick a Pico one, because most people use it. If I connect power to a Pico turnout straight out of the box, and I connect positive there and negative there, it doesn't matter. Obviously, because it was DCC, that would be going positive, negative is whatever frequency it is. Okay, but let's just say that's positive, it's negative at that instant of time. This blue rail is going to be positive. This rail here in red, that's going to be positive. So is that. So is that. So is this. And all of this, even down, you've got positive and negative. Right? Notice a small gap. Notice also that the contact to put positive across there is just this rail touching that rail. Some early Pico points, I think the Code 100 may still do it. They've got a little underneath the rail. They've got this little lug, and I think it's on that one, and it just clips underneath the other rail and just makes contact. If you think about it, that's not a really good contact. How many times have you run a point over and it stops, and then you just press the rail and the loco moves on? You've got a bad contact. So let's look at it as it is, straight out of the box. If you put a controller there and run a loco, that would go up there. Notice how there's a positive there and a positive there, and a positive there and a negative there, and that's what you want. But positive and positive is actually a short circuit. I'm going to turn over and I'm going to show you the opposite way, if it's switched. Here, same thing, negative, positive, but now, and I've drawn this, that's right, I've drawn this right. So there's negative, that negative feeds up there, because of this contact here, nothing else, feeds up there. That's negative, so there's a short, now there's a short there, and you can prove this. If you've got a multimeter and a live frog point, and put a multimeter across there, if it's turned against there, you'll always have a short, whichever one's turned away, which is why you're going to use insulating fish plates. So the train's now going up this way, so it's negative, negative, negative. That's all negative. That's positive, and you haven't got a short because that's not touching. But there's only a small gap. See if you can think of a problem there could be when a wheel goes past there. And the problem is that, and you've probably seen it, depending on the back-to-back of your wheels and the gap, and it's worse on code 75, because it's just a bit finer, as a train goes over, the wheel can short out, and you'll often get a spark. It might make the train stutter, it might make it stop. Now, on DC, that's not too bad. On DCC, if you get a short, the DCC system trips out and thing stops. So, you can see now, as I said, it will work. You can run them like that. Even Pico out the box, Pico O gauge out the box, you can run like that. You still will have a short. You still have a short. Now, that's that one done. So how do we wire these things? How do we wire these things? make sure we get better contact here. In other words, don't rely on that. And make sure that you don't have this gap where positive meets negative or negative meets positive, depending on which way it's switched. So, and I'm hoping this will make sense. First of all, and this regardless of AC or DC, you have to really, because this is changing, at the minimum you've got to put an isolating fish plate there and there. Personally, when I'm doing it, I isolate a lot. I put 4 in, 1, 2, 3, 4. They're not deer, so I just put them in. Right? And then you can have another feed up there if it's DC. If it's DCC, it's coming off your bus, or DC, it's another section. It doesn't matter. In fact, you can even make that the same section, because it won't affect it, because if it's a positive there, negative there, if it's a short there, because this is isolated, it's not going to make any difference. Okay. How do we solve some of these problems? First of all, you put a little bond on the underside between the stock rail and the adjacent switchblade. So you put 2 in, 1 there and 1 there. Now what that will do, it takes away your reliability of that touching contact. Now it's bonded, almost like putting a bond between 2 pieces of track instead of relying on fish plates. Yeah, they work, but what happens when a bit of corrosion gets in, or if it's outdoors? So you always bond it, put a dropper down underneath, or put a wire, solder a little wire from one to the other. You're not relying on fish plates. But as it stands, if that was that point straight out of the box, you've now got created for yourself another problem. And the problem is, remember, thinking back to this, if I pulled this apart and bonded that, well, now you've got a problem where it goes through there, through there, through there, through there. And that is called a short circuit. How do we get rid of that short circuit? How do we make it so it operates correctly? It's very simple. You use a little changeover switch. A changeover switch, it looks like this. There's it could be 2 outputs and 1 input, and you switch it and it goes bang, 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 bang. Or, depending on how you want to feed it, it's 2 inputs and 1 output. And that's exactly what we're going to, so we're using it as 2 inputs and 1 output. So here goes. We put the bonds in, we fix the short by isolating there and there. Now if you look at Pico track, if you look at Pico O-gauge track, you'll notice there's a little, you'll see that it's not one piece of rail, there's a bit of plastic, and if you turn the point over, you will see a little strap. They put a little strap in. All you do is break those straps. Underneath the rail, there's a little hole, and you'll see a little piece of soldered wire. Just pull those out. As soon as you pull those out, this is now isolated. So that can only go to there, and that can only go to there. No more short. But now, this is dead. So this is where the switch comes in. You will also notice at a lot of points there's a wire hanging down the middle. Doesn't have to be, like if you're making track like C&L, there's not. You've actually got to put the wire, solder a wire, you can solder anywhere, right? Solder a wire there or there, doesn't matter, it doesn't have to be at the tip, okay? So you solder a wire, the wire comes down there, I've just shown it, going over there, in other words I put a little hoop, there's no connection there, so wire over there and there. And I put that to an input of a switch. One of those little switches, one way or the other, 1 input, 2 outputs. One rail, actually, no, that's wrong actually, these are the inputs, sorry, and that's the output. So one rail connects to one stock rail, one terminal connects to one stock rail, the other one connects to the other. So there's always positive and negative on here. Depending on which way the switch is set, this will either be positive or negative. You're just going to make sure that it's the right way. There's only two ways you can get. You can either, if you wire this up, you can either. There's only two ways to get it. It's either right or wrong, because you've only got two choices. It's either positive or negative. If you make that positive, and it's going straight across, and that's negative, you're going to get a short. All you've got to do is switch these two wires around, and it will work. You can test it with a multimeter, a continuity tester, before you put them in. And these switches in Pico, especially in O gauge one, if you can actually put in that little, if you lift off that cover, you can get a little micro switch. You've probably seen them. You can get them in hot. It looks like that. There's 3 terminals, and there's a little arm comes down out like that, and it's got a little button. And what happens is, as the tie bar goes across, there's a thing like that, and it pushes it in. So that will be they're your inputs, positive and negative, and depending on which way this is in or out, that will be positive or that will be negative. That is what goes to there. I use those on Pico points. If you're using C&L, Pico points aren't so great because you don't have a changeover switch. On my layout, I've taken all the changeover switches. I use Cobalt turnout motors, or Tortoise you can use. And on those, built into the switch, you've got the positive, you've got your power, which on Tortoise is 1 and 8, and you've got 6 other terminals. Built into those Cobalt motors, and I assume Tortoise is exactly the same, you have 2 extra, you've got another 6 contacts, you've got 2 of these changeover switches built in. So that's all you've got to do, and that works. And it doesn't matter if you're running DC or DCC, that's how you do it. You have to isolate there. As I said, the reason it doesn't matter is because at any given point in DCC, if one instant in time, 1 nanosecond in time, it's going to be positive or negative. And it's going to be somewhere in that, where is it? Cycle. It's going to be somewhere in that cycle, where I put it. Doesn't matter. Yeah. Depending on when you said, now, it could be there, it could be there, it could be there or there. But it's if it's frozen in time, it's still a circuit. It's still, the whole idea is that you have a circuit down one rail, back through the other, and you don't get any shorts. That's it. There's nothing electronic about it. There's no theory to understand, apart from the stuff I've just told you. It works. And if you check the Pico, a little instruction to get with the Pico, that's exactly how they tell you to wire it. Anyway, I hope it helps, because I know some people just get confused by it. Thanks for watching.